Hi guys, it's Miss Ruiz here. Today we're going to be taking notes for the next module 4.2, which is constant rates of change. So please make sure you title your paper, make sure you write today's date you're taking the notes, pause the video and copy down all of the notes you see on this first sheet here. I will scroll it up so you can pause and get the rest before we get started. All right, so let's take a look at what we're going to be learning here. So the essential question that we're going to be working on is how can you identify and represent proportional relationships? So we're going to have two examples in this video. One of them, we're going to learn how to read through the word problem. It also can be presented to you in a graph or in a table, and identify if the situation being presented is or is not a proportional relationship. And then representing, we're going to be looking at a proportional relationship and then writing the equation that represents that proportional relationship. So vocabulary words that we're going to be using, one of the first ones here is a rate of change. And a rate of change is a rate. So we're talking about fractions here when we use the words rate and ratio. We're looking at fractions, but this is a rate that describes how one quantity changes when it's in relationship to another quantity. You'll see that in action shortly. A proportional relationship is a relationship between two quantities where the rate of change is constant. Okay, so we're going to be finding the rate of change between these two quantities, and we're going to call them for right now x and y. So we're going to look at the relationship between whatever x and whatever y's are given and find to see if the relationship between them is constant. Okay. When we find a proportional relationship, we're going to have to write an equation for it. So let's take this here step by step because it can sound more complex explaining it than it actually is doing it. So it says here when we're talking about writing an equation for a proportional relationship, a proportional relationship between x and y is described using this equation right here. Okay. So up top where I was talking about when we represent a proportional relationship, wait, hold on. When we talk about representing a proportional relationship, we're going to have to represent it by using this equation. Okay, so when we see the equation y equals kx, and I'm going to explain what all those letters mean, what all those variables mean. But this equation is what we use when we figure out that what's being presented is a proportional relationship, and then we're going to create this equation that represents that situation. Okay, the letter K in this relationship is the newest variable that you're going to have to learn. So let's talk about K. The letter K, when we see the letter K, it's, whoops, when we see the letter K is representing what's called the constant of proportionality. The constant of proportionality. It's when we see a proportional relationship and it's got this rate of change that is constant in it. So that's why we call it constant of proportionality. You will hear me address it as the constant. The letter K is the constant. Then we have these two variables, x and y. So here off to the side, x is known as the independent variable. Okay, so when we're reading through a word problem, you're going to see in this first example, we're going to be looking at two quantities. One of the quantities is something that's going to happen or just is, and it doesn't depend on anything else. The y variable is what depends on something. So it'll make more sense when we actually look at a problem. But just for now, keep in mind that x is the independent variable, y is the dependent variable. So coming back here to the equation of a proportional relationship, y equals kx. This is a one-step equation in multiplication. And you see that k, the constant of proportionality, is being multiplied by x, the independent variable. If you take the constant of proportionality and multiply it by x, it will equal y, our dependent variable. Since this is a one-step equation in multiplication, there are other things we'll be able to do with this equation, as you will see moving forward. So the constant of proportionality represents the rate of change or the constant ratio between x and y. The value, and now I'm reading down here, the value of k, so the value of k is represented by this equation here. So if you take a look at the difference between this equation and this equation, you'll see that the top equation is a multiplication and this equation is a division equation. It is the inverse. Okay, so if we are looking to find k, we want to look at this relationship and find out if it is a proportional relationship. We're going to take the variables y and divide it by x, and that will equal our constant. We'll do that for every quantity that's every pair of quantities that's presented in the proportional relationship. So we're going to really use this to find k. Okay, so this equation we'll use to find the constant of proportionality. This top equation we'll use to represent the proportional relationship. All right, let's move on because, like I said, this will make a lot more sense when we're actually using it with numbers. The last thing I want to remind you of is what a proportion is. So in 6th grade, you guys used proportions a lot in previous years. So a proportion is a statement that that shows the two rates or ratios are equivalent. So if we've just finished working with unit rates, all of those were equivalent. So if something, we're traveling 6 miles in 2 hours, I can create an equivalent fraction or equivalent ratio to that, and those two will be proportional relationships. One way you can check to see if you have a proportional relationship is to cross multiply, and they should be equal. So here, if I multiply 6 times 1, it should equal the multiplication of 2 times 3. They do, they both equal 6. And so this is a proportional relationship. Okay? Same thing on the other side. If I multiply 2 times 2, I'm going to get 4. 4 times 1, I'm also going to get 4 on this side. This is a proportional relationship, a proportion. All right, let's take a look at the first example. So for these here, you do not need to copy down the word problem into your notebook. However, I do want you to copy down this table, all of the math that we do, and all of the notes that I have on the side. You need to have that in your notebook. Please label in your notebook this as example 1. I'll be looking for that when I check your notebooks. All right, so here we have Kaylee. She has a job, and Kaylee is earning money by dog sitting. So based on the table, is the relationship between the amount she earns and the number of days. So those are our two rates, right? The amount she earns and the number of days. Remember, we start with words. Is that a proportional relationship? So these are an example of one of the ones where we have to identify to see if this is a proportional relationship, okay? When we start doing these problems, the first thing we're going to do is label X and Y, okay? Which one of these words or phrases represents an independent variable and which one is dependent, okay? So if you take a look, we have number of days. Well, whether Kaylee works or not, the days are going to pass. The days don't depend on anything or anyone. Time will pass. However, the amount of money she earns is absolutely dependent on the days that she works. So Y, our dependent variable, would be the amount of money earned. X, the independent variable, would be the days. So we're always going to start labeling our X and our Y before we even begin. Once we do that, now we can apply our equation. We are looking to see if this is a proportional relationship. So in other words, I'm looking to see, is there a constant of proportionality? When I'm trying to find if there's a constant of proportionality, I'm going to use the equation. The constant of proportionality equals the division of y divided by x. Well, since I have labeled my y and my x, I'm going to take each one of these pairs and I'm going to do the division for each pair y divided by x. So be careful not to do it only because it's represented in one way. You have to actually focus and pay attention that you're dividing the y by the x. So let's take a look at that. In this first example here, my y is 16. So I should have 16. Okay, my y is 16. So if you take a look here, I have 16 and my x is 1. So there's my 1. And that is in the simplest form. So my k for this one would be 16. It equals to 16. So let's go on and see the next day. So for day 2, my y would be $32. And my days, my x value would be 2 days. So I have here 32 divided by 2, y divided by x. And we simplify that. You can divide both of these by 2, and they will simplify. That will simplify to $16 in one day. Okay, so far we've got the same simplification. It's simplifying to the same number, which equals $16. All right, let's take a look at the next one. On the next day, day number 3, my y value is 48. So in the numerator, I should have 48 as I do here. The denominator would be your x value, which is 3. So that is 48 divided by 3, or 48 over 3, which simplifies dividing them both by 3, making it, we got 16 for one day, $16 for one day. So again, it simplifies to the $16. Continuing on, the next day, we have our y value is 64. So you have 64 divided by 4. That simplifies also to $16 in one day. We have the same rate there. And last day is day number 5. So my x value would be $80. And days is $5. 80 divided by the 5, we have $16 for a day. So when you apply the equation of y divided by x, you're going to do that for each pair, for each quantity, each pair of quantities in the relationship. If you get if they simplify to the same number, the same quantity, this represents a proportional relationship. So at this point, we have identified that it is a proportional relationship, and we found the constant of proportionality, K, which is our $16 per day. Okay, so just like we did with unit rates, we started with words, we're going to end with words, which will say here that the constant rate of change is $16 per day. Okay, and that does tell us that this is a proportional relationship. So yes, when we read this word problem, this is a proportional relationship. We use y divided by x to find the constant of proportionality to determine that it is a proportional relationship. And we found that the constant rate of change is $16 per day. Okay. Here is a table that I would like for you guys to try. So please pause the video now. Read the word problem and apply the same thing that we just did. Remember, the first thing you're going to do is label one of these words, time or distance, as x, and the other one as y. And you're going to use k equals y divided by x on with each pair of numbers in order to see if they divide to the same number. If they do, it is a proportional relationship, and you can tell me what the constant rate of change is. If they do not, then your answer would be no, this is not a proportional relationship because they're not equal. Okay, so go ahead and try that, and we'll come back and check to see what you got. All right, so hopefully your answer here would be no. This is not a proportional relationship. The rates aren't equal. All right. And so let's see how that works out. How did you do this problem? So what you're going to want to do is for each one, we're going to do our y over our x. And in order to figure out which one is y and which one is x, I'm going to take a look at what they are. So we have time and distance. Well, time is going to pass no matter what, but the distance that's traveled is dependent on the time. So this is my x value and this is my y value. And now I would simply divide each one of these. So in the first rate, I have 65 divided by 1. That's going to equal 65. The second rate, we have 120 for our y value divided by 2. Well, that's going to simplify down to 60. At this moment, I know that this is not a proportional relationship because those two numbers are different. If this were a proportional relationship, all of them would be. But we can continue just to make sure you guys got everything else correct. So now I would do for the next one is 195 divided by 3. That also equals 65. The next one is 220. Let's come over here. Divided by 4. And that one equals down, I think I got 55 there. And 300 for the last one divided by 5, down to 60. So because these numbers are different, they're not all the same constant rate of change. This is not a proportional relationship. There is no constant of proportionality. All right, let's move on to the next example. So same thing here. You do not need to write down the word problems or all of the writing on the text. However, I do want you to label this example 2, and I would like for you to make sure you copy down the table, label your x and y variables, and show the math, the calculations that we're doing to find this out. Okay? So the 2 pounds of cashews shown cost $19 and 8 pounds cost $76. Show that the relationship between the number of pounds of cashews and the cost is a proportional relationship. Then write an equation for the relationship. So first we're going to have to find if it is a proportional relationship. We're going to do the same thing that we did in the last two examples. So we're going to divide our y divided by our x. And so we'll take the first set of numbers. And if you take a look here, they've already labeled the words for us. This is y is our cost. This is our x. And the first quantities would be 19 divided by 2, and that's going to equal $9.50. The second rate, we have $28.50 divided by the 3 pounds. That also simplifies down to $9.50. And $76 divided by the 8 pounds, $9.50. So there we can see that this is a proportional relationship. We found a constant of proportionality by using y divided by x. That's how we find the constant of proportionality. Okay, so now we have found it. We know that they are constant, so the relationship is proportional. And the constant rate of change is $9.50 per pound. Now, we have to write an equation to represent this. So above in the notes, I told you that we would use K equals y divided by x to find the constant, right? We use that to find the constant, and we did that. Now that we found the constant, we're going to use the equation y equals kx to represent the proportional relationship, right? And we know these variables already. Our x value are all of our independent variables, so that was the number of pounds. The y is the cost. Excuse me. So very simply, all we have to do is write it in this form, and the only number we need to put in the equation would be the constant of proportionality. So here it is. This is how you would represent it using this equation here, okay? So all you're going to do when you write these equations, you leave the y as a variable, you leave your x as a variable, and the actual constant of proportionality that you find, $9.09.5 or $9.50, however you want to write it, that would be your equation to represent this. All right. Let's see here. We have here one your turn for you guys to do. So if you would pause the videos, read this, you're going to apply the same thing. You're going to find out if the relationship is a proportional relationship. If it is, then you're going to write an equation in the form of y equals kx to represent that proportional relationship. Okay. So pause that. I'm actually not going to do this one in the video. I'm going to leave this and check this one in class when I check through your notebooks. So pause that. Try that one. And one more shot I'd like for you guys to try are these three problems here. You do not need to all you need to do is write the number. So you're going to write numbers 1, 2, and 3, and show me your words, your X and Y values, and the numbers. So you might as well just write the tables out. Show me if it's proportional or not. I want to see how you found the constant of proportionality, and write an equation for the bottom for number 2 and number 3. All right, this page will also be listed in Canvas for you guys to do if you need to look at it there, but you can just pause the video here and use it. All right, I will see you in the next class.